about. So it said that each network node maintains a distance vector table containing the distances from itself to all possible destination nodes. Distance are based on a chosen metric. So usually it can be the number of hops, it can be the bandwidth, it can be the delay, it can be the throughput, it can be the with the congregation, according to the congregation. So many issues can be there, right? So we have seen that the weight, right, of that the link, so that the weight has been given, that the weight can be with that these different metrics. Okay, so here on it said router transmits its distance vector table to each of its neighbor, actually that directly connected to it periodically. Okay, so it said that every node, each network node maintains a distance vector table, right? So every node are going to be have a table containing the distances from itself to all possible destination nodes. And here it said router transmits its distance vector table to each of its neighbors. Of course, the neighbors should need to be directed neighbor. For example, here the for you the directed neighbor is V, W, and X. Okay, so that the directed neighbor, it is going to be transmit to each its neighbors periodically. So the table, the distance vector table, the router is going to be have, that can be recalculated. So when it is going to be recalculated, if it receives a distance vector table from a neighbor containing the different information than before, so each of the router going to be have a table. So say that this is the node A and B. So if it discovers that a link to a neighbor has gone down or up, the topology changes. So that means here that the node, every node is having a table, that node A and B. So if there any change is happening in that the routing table of A, I mean the distance vector table of A, then it is going to be saying that the update, okay, that there is a change, the update is going to be given to B. Okay, so of course that node should need to be the direct neighbor of A. All right, so when that the changes is going to be occurred into the table, that the changes for updating the changes, I mean the neighbor node should need to be also update those changes. So when that the B is going to be received that the table, and he's going to be compare, B is going to be compare its table with that the updated table it got from A. According to that, B is also going to be revise its table, update its table. Okay, so that is actually said here. So it can be happen for that if the node has a node has date. Okay, a neighbor node has date, so table is going to be changed because that node is not available. So that is going to be updated into the table that this node is not available for something like that. Or it can be happen that, I mean, you are finding that the least cost path from a node, you are finding the a least cost path. So the value you are having in the table, compare with that, you got a least cost path to the same node. So that means that is going to be also updated. So distance to all destinations are computing using the informations from the neighbor distance vectors. Okay, so that is what I mean. The least cost is going to be least cost paths are going to be discovered through that these tables that they are actually sending to each other, of course that the to the directed nodes or directed neighbors. The DV calculation is based on minimizing the cost to each destination. So from its DV, a router can directly derive its routing table. A routing information protocol is an example of distance vector routing protocol. So we have already seen it into that our lab class, the RIP routing protocol, right? So this the RIP routing protocol is based on actually the distance vector algorithm. So now let's see that we are having an example here that we can see that there are three nodes we are having. So uh, so that means all that the three nodes are going to be have a table. Okay, the as we say it here, that distance vector table. So in that the table, it is going to be keep the information, okay, about the nodes that it is directly connected with. Okay, so in the table there is going to be from any node you're starting that you can form, for example, x, so you can go to that x to y, x to z. Similarly, that you can go to that the x to y and x z y, there is another path. So for each node, if you want to reach to the other node, there are actually two paths for each of them. For example, z, you want to go to x, so you can go directly and you can go through that z, y, x. If from y you want to go, for example, x, then you can come y to x, or you can come y, z, x. So that means you are going to be here in this network, you're having the three nodes. So it's suggesting that you can go from a node to that all other nodes to itself and all other nodes. So that means if I'm saying that this is my table for that the node x, this is my distance vector table from the node x. So from the x, uh, how we can go to that x, y, and z. So look that first of all, that the table I am having, that is going to be with all infinity sign. Okay, there is nothing below, no value is there. Just it know that there are three nodes into this network. There is no value. So if there is no value, then we are representing with that the infinity sign. So means that information unknown. So now for we are having the three nodes. For each of the nodes, you can see that we are having the table. So we are having the xyz because we are having the three nodes here, that xyz. So from xyz you can go to xyz, and what is going to be cost for them, that actually we are interested to calculate here through that the distance vector uh, distance vector routing algorithm. So now for the x table, as I say that, I mean, for the x table this is all empty. For the y table, first time it is going to be all empty. If the value is not there, say that there is no value, there is no cost has been given. So that means each of them are going to be have an empty table. They do not know that how to reach to that the other nodes. Similarly, y is going to be have here that y table is going to be similar like this, same, that it is actually for y. Now the things are unknown, right? And for the j table, if it is a j table, then also it's all empty, and j is this is actually unknown. J do not know how to go to the other nodes. All right, now you can see that now we have given a cost that for the links we are having x to y, or y to x, y to z, or z to y, or x to z, or z to x, something like that. So that the cost here has been given. So according to the cost, now the tables we are going to be updated. So the node x, node y, and node z. So now look at the node x table. So from that the x, we are going to be see that if we want to go from x to x, so it is itself you are going to u, so that means it is going to be 0. Now you are going to be move to x to y. So if you're going from x to y, can I go directly x to y? Yes. What is the cost? The cost is 2. So that the 2 I am writing here. So now can I go from x to z directly? Yes, I can go directly x to z. What is the cost? 7. So I have written the 7. So now the table was, I mean, without any value on the table. I mean, all was empty, but now we have got some value. So that means the table has been updated on the x. So that means he is going to be let it know to that its direct neighbor y and z. So that is that the, I mean, this is that the next table. Actually, after these tables, this is that the another column, the what is going to be the update, right? So that the updates happen here. This is the this is the, with the arrow it has shown that it is sent to that the y. So this is my y, so we are going to be considered as row wise. Okay, so it is sending to that the y, because y is the direct node, as well as the z. So this that the arrow is showing that it is the update has been sent to that the z. So that means it is saying that the updates to that the y and z, because y and z is the direct neighbor from that the node x. Now you come that similarly for the node y, we are updating the information. So this is the node y. So from that the node y, can you go to the directly x? Yes, you can go directly to y. So what is that the cost? 2. So that the 2 you have written. you're going from y to y, so that is no value, 0, right? So that is what 0 we have written. You can go from y to z directly. Yes, y to z you can go directly. What is the cost? 1. So you have written 1. Now there is an update. The all the field was empty, but now the value, there are some values are added into this table. So that means the update is need to be sent to that node x and as well as to node z. All right, so that the update has been sent to the node x and node z. Now if you're coming to the z table, so you can say that z2x, can you go to that z2x directly? Yes, you can go to the z2x directly. What is the cost? It is 7. So you're writing the 7. Can you go from the z to y directly? Yes, you can go directly z to y. That is the cost is 1. And z to z, it is going to be 0, right? So that is that we are writing. So that means here also we got some changes. So that means the update is going to be sent to the node x as well as to node y. Okay, so when that it gets the update, right? So there is another column I have not written there, so I'll make it another column here like that. So this is going to be that this his own table, and he gets the update from that the x and sorry, y and z. So that the from the y he has updated it towards the empty, so he has updated to 2, 0 and 1 from here. Okay, and also that he got the update from the jet, so he has make it 710 710. Do you understand that?
Yes, sir.
স্যার আবার একটু বলবেন স্যার আপডেটটা কিভাবে হইতেছে মানে
Yeah, so
আপডেট
that
করার পরে
yeah, so that the changes has been done, I mean, as because the table has been updated for the node x, so that update should need to be given to the direct nodes y and z. So here y has got some updates, so that means y is going to be let it know to the node x as well as node z. That node z table has been changed, right? New values are added, so it is going to be informed to the node x and node y because they are the direct neighbors, right? It is x from the x. So if I'm having the another neighbor here, say that w, so that means if the w is having some value, right? So that means for the w also there is going to be a table. Okay, so that means you have to add here the w. There is going to be the 4 nodes w, something like that. You understand or not? So
ইয়েস স্যার
look at
স্যার
the
আপডেটটা
direct
খালি
node.
জানাই দিতে হবে স্যার।
জানাই দিতে হবে মানে কি?
স্যার এই যে আমরা যে আপডেট গুলো করছি ওগুলো কি মানে সাপোজ জেড এর টেবিলে আপডেট হয়েছে
Right.
তো কি
So that the
এক্স এন্ড
update
ওয়াই
is
কে
happened here. You are going to be let it know to your direct neighbors. So node X has some updates. So who are the direct neighbor? Look at to the graph. Who are that
ওয়াই
the
এন্ড
direct
জেড
ওয়াই
neighbor?
এন্ড
Y and Z, right? So that means the update is going to be sent to that the Y and Z into this example. Do you understand that?
ইয়েস স্যার।
স্যার আন্ডারস্ট্যান্ড
All right. So now come that. So this is that the update. I mean, according to the update, it is 0 to 7, 201, and 710. So it is going to be here what? Same thing, because it is getting the update from X, the node Y. So this is the Y table, this is the X table, right? So now that what is going to be happen? Same thing, it is going to be here 0 to 7 for X and 201 and 710. Isn't it or not? Understand or not? Why?
ইয়েস
ইয়েস
স্যার।
Because
স্যার
Y is having
Yes,
this
sir.
value and it takes the update from the X as well as get the update from the Z. So that means all the values are going to be same, isn't it or not?
ইয়েস স্যার।
ইয়েস স্যার
ইয়েস স্যার।
Okay, just a moment. Now, after this update, so now you are going to be apply that Bellman-Ford equation to check that, I mean, the cost we have got from a node to that the other node, the cost we have got that 0 to 7, 201, 710. So are they they are really the least cost path to them or not? For example, you're going from X to Y, the cost is 2. Is it that the least cost or not? We are going to be check it. From X to Z, the cost is 7. So is it that the least cost path from going from the X to Z? So you are going to be check for that. And for every cases we are going to be do that. and we are going to be apply here that the Bellman-Ford equation that actually we have seen in the last class. So now come here that the value was here 7, right? So now you can check that, I mean, the value you are having, that x to x, definitely it is going to be 0. X to x, it is going to be 0. So this is going to be list. I mean, definitely x to x, it is going to be 0. So there is no need to check. Now come to that x to y. So you want to go to x to y, right? So this is one path, cost of x to y plus dy to y, because y is the destination itself, isn't it? Cost of x to y, plus dy to y, right? Why to y? Because y is my destination that I am going for, searching for x to y, right? Do you understand that? So where from I get this formula? Yesterday that we have done it, right?
Bellman for.
This one, right? This is that the equation actually we are using, cost of x to v plus dv to y. So now come here that what is the another path you're having? So you're having the cost of x to z. So this is the another path. You can see that cost of x to z plus, now it is going to be dz to y, right? Dz to y. So now if you are
স্যার ডি
calculating,
ওয়াই কিভাবে?
huh?
স্যার
Sorry.
ডিজেড টু ওয়াই ডেস্টিনেশন ডিজেড টু ওয়াই কিভাবে হলো স্যার?
Yeah, where from you're going? You're starting from x. Where you'll go? Y, isn't it or not?
এ স্যার
So there is one path, direct path, that x to y. So for that you have written that cost of x to y plus y to y. Why y to y? Because y is the destination itself. But
জি
if you're
স্যার
going from this way, then it is going to be cost of x to z. So now you have to go from z to y, right? So that is why that dz to y. Understand or not?
জি স্যার জি স্যার আন্ডারস্ট্যান্ড
All right.
তো এখানে কি ওয়াই
So,
ডেস্টিনেশন?
yes, at this moment, because we are look in the table, we say that we want to go from x to y. At this moment, the destination is y. We are checking for this, right?
ইয়েস স্যার
So now, if you're just simply writing it here that it is going to be 2 plus 0. So what is the value you got? 2. And here you got x to z is 7 and plus dz to y is your 1. So it is getting how much? 8. So between these two, which is the least one? Least cost.
2.
So what we are having? 2. Yes or no?
Yes, sir.
So that means we are not going to be changed because we are already having in the table the least cost path. Now we actually interested to go from that the node x to node z. So find it out that what is going to be happen here. So here we want to go from node x to z. So we are having cost of I'm only writing c means here the cost. Okay, cost of x to z plus dz to z, because z is my destination now, right? Dz to
ইয়েস
z.
স্যার
Yeah. So another is going to be the cost of, now we can go this way, x to y and dy to z, right? Cost of x to y and dy to z. Okay, so now just put the values. So cost of x to z is your 7 and dz to z is your 0, so it is 7. And here cost of x to y is your 2 plus y to z is your 1, so it is 3. Understand or not? So now compare these two values, 7 and 3. So which one is least cost? 3. And what we are having? 7. Okay, so that means there is a update is required, so that the update we have written here. Understand?
স্যার বুঝি নাই স্যার আবার আবার Last
So
part.
that you have understood, right? That we have find out that the cost for
Yes,
going
sir.
from X to Z, we are find out the cost. One cost is the 7, another cost is the. Well, I'm back. So can you hear me now?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah. So we have found here that the we are fine. You want to go from that X to Z. So from that the X to Z, we are having the two paths. So from that the two paths we got the value. With one path we got the value 7, and another path we got the value 3. You can see here also that X to Z is 7 and X Y Z is actually 2 plus 1 3. So now that the 3 is the least cost among these two. But
Yes,
in the
sir.
table, what we are having? In the table, you are having the 7, isn't it or not? So that means, as because 3 is the least cost, so we have to update it. We are updating it 7 to 3. Do you understand that or not?
Yes,
Yes,
sir.
sir.
বুঝতে
Now
পারছি।
I understand.
Right.
স্যার
So now, yeah.
স্যার এখানে যে কস্ট যেটা দেওয়া আছে স্যার, এটা হচ্ছে একবারে আপডেটেড, তাই না স্যার? এর আগে যেটা হচ্ছে সেটা হচ্ছে স্যার 027, এটার পরে আপডেটেড হয়েছে 023।
Right,
ইজ ইট?
right. There is no change with these two values because these are the minimum cost
ইয়েস
already,
স্যার,
right?
ইয়েস।
But we have found that this the cost here, the 7 it was not the least cost for going from X to Z. So that's why we have updated this one, isn't it or not? Do you understand?
ইয়েস স্যার।
So that means we can see that there is an update into this table, right? So because one value has been changed, so that means what is going to be happen? The node X is going to be given update to Y, as well as it is going to be given update to Z, to its direct neighbors, right? Node X direct neighbor is to Y and Z, so it's going to be sent that the update. Understand?
Yes, sir.
ইয়েস স্যার।
All right. So now next, let's take that for that the Y, right? Y table, that the costs are actually here we are having the cost. The costs are actually minimum or not. So if you're going from Y to X, look that you're going from Y to X. So that can be the cost of Y to X plus dx to X. That means 2 plus 0 is going to be 2. And if you're going to this way, then it's going to be cost of Y to Z plus dz to X. So that means it is going to be 1 plus 7 equals 8. So between these two, we can see that this is the least cost. What we are having to itself. So there is no update. Understand or not? বুঝলা তো নাকি?
Yes,
স্যার
yes, sir.
We had the 2, so we are keeping it 2 because the 2 is the least cost between these two paths. So now Y to Y you are going, that is definitely 0. We do not need to test. It's 0 already, so we do not need to test. Y to Z. So if you're going from Y to Z, then the formula is cost of Y to Z plus dz to Z. So that means it is going to be 1 plus 0. It is going to be 1. And if you're coming for the other path, then it is going to be cost of Y to X plus dx to Z. So that is going to be 2 plus 7. That is going to be 9. So we are having the 1 and 9. So we can see that 1 is the least cost. What I am having in the table? 1. So that means I do not need to make update. We are keeping, we have seen that in the Y table, there is no change. What was the value we had? We are having the same value. So that means we do not need to send the updates. Do you understand that or not?
জি স্যার, বুঝতে পারছি।
All right. So now come to the node Z. So in the node Z, the cost, the from node Z to the other nodes, the cost or the minimum or not, that you're going to be checked. So look that from the node Z you want to go to node X. So this is your Z, this is your X, you want to come here. So the cost of Z to X plus dx to X. So that means it is going to be 7 plus 0. It is going to be 7. And now you want to go other way, that is the cost of Z to Y, that is your 1, plus dy to X, that is your 2. So that means it is 3. So between these two values, you can see that this is your 3 is your least cost. What is the value you are having here? 7.
Seven.
That means That means update is required, so that you can see that we have made the update. Understand?
जी सर.
Yes.
Now you want to go from Z to Y. Z to Y. So if you're going from Z to Y, so this is that node Z, and this is that the node Y, right? Z to Y you want to go. So that cost of Z to Y plus dy to Y. So that means it is going to be 1 plus 0,
1 plus 0.
1. And other way, if you want to go from Z to Y, that is the cost of Z to X, that is 7, plus cost of, sorry, dx to Y. So dx to Y is my 2. So that means here it is going to be 9. So we can see that the least cost is my 1.
1.
So what is the value you are having here? 1. So that means there is no need of changes. Understand? So now cost of Z to Z, it is 0, so we do not need to check. Okay, so that means we can see that in this table also a change has come. Okay, so that means this table updates you should need to be give to node X and node to Y and node Y, the direct nodes. To its direct nodes you have to give them. All right. So now you can see that after getting the updates, what is happening? So it was 0 to 3. It is its own table, that node X own table. So 0 to 3, and the Y node values are not changed. So it is going to be as it is 201. But from the Z you have got an update into the node X. So it was the 710. Now you are updating it according to that new values, that is the 310. Right? So there is the change actually here. So now you are coming to that the Y table. So look that it was that the previous value, the older value 0 to 7, but it gets the update. After getting the update, it has changed the values 0 to 3. So that the change is actually here. So the node Y is updated. That X to Z, sorry, Y to Z, it was sorry, X to Z it was 7. So now it is X to Z, it is 3. Okay. So that the update, after getting the update, he updated the table, and it is his information. So his information did not change. So it is as it is. And also he got an update from that the node table jet. So it is getting the update. So it was the 710. So you can see that it has actually now 310. The change is here, 7 to 3 that we have got, right? 7 to 3. I'm sorry. Yeah. So 7 to 3 jet node, right? So that the jet information is updated 310. Now you can come here that the Z table. So that you can see that it was the older values 0 to 7. So he get the updates. After getting the update, he has updated the table 0 to 3. So the change is here, right? 3. So now Y table has not any change. So he did not get any update from Y because there was no change. So it is as it is. That it has what it had. Now it is same. So now you are going for that the Z table information. So it is with himself itself that the changes happen. So it is keeping as it is. Do you understand it or not?
Sir,
Yes, sir.
could you repeat the last part, sir? I didn't understand about this.
Last part what? Last part which one? Note Z table.
Yes, sir.
So you understand that how to update the table, right?
Yes, sir. Yes.
So if you updated it already, right? So now you get the update in the node Z. From which node you got the update? The node X. I know the value was 0 to 7. Update was the 0 to 3. So there is an update. So that the information you are sending, that this information you are sending to that the node Z. So the node Z can see that in this table he had that 0 to 7, and he's compared this table with that the updated information of sent by X. So you can see that the change is here. So he has made that the update here. Is it clear or not?
Yes, sir.
Okay. Is there any other question for this?
স্যার এক্সামে আসলে কিভাবে করবো স্যার? এখানে এখানে তো অনেক ভাবে ইয়ে করে দেওয়া আছে, তীর চিহ্ন দেওয়া আছে, তো আমরা কিভাবে করবো স্যার এক্সাম?
I don't understand.
স্যার এখানে তো অনেকগুলো ডিরেকশন দেওয়া আছে, তারপরে ইয়ে দেওয়া আছে, আমরা এক্সামে আসলে কিভাবে করবো, পরীক্ষা এটা কিভাবে করবো সেটা যদি
The
বলতেন।
arrows are given if there is an update. Okay, so that you are going to be give the, I mean you are going to be show that the updates also with the arrows. If there is an update in a table, then you should need to be inform it to that inform it to from that node to the direct node. Say that here for the node X, so what the direct node here Y and Z. So if there is an update, so you have sent the update to that the node Y and Z, isn't it or not? If there is an update, then that the update is going to be let node to that the direct node from Y. You can see that X and Z. So you are going to be sent that the update to X and Z. So in the Z table, there is an update. So that means you're going to be sent it to that node X and Y. So you can see that from Z, X and Y are the direct neighbors. Understand?
Yes, sir.
Yes, sir.
So all right. So can you close this? Can you go for the next?
Yes, sir.
All right. So we have already discussed the link state routing algorithm. So that the two algorithms that we have discussed, the distance vector and that the link state routing algorithm. So we have covered these two, and I say that the distance vector, the Belmont fold algorithm, and link state Dijkstra algorithm. These are the algorithms we have covered. So I said that in the midterm there is going to be a problem with from these two algorithms. One problem is going to be asked. Okay, clear.
Yes, sir.
All right. So now we can go back to that the slide number 3, that where from actually we jump to that the routing algorithm. So here we say that we know that the network responsibility is that for sending the, I mean, for finding the path and sending the packets from the source to the destination. So A is my source and B is my destination. So here, I mean, the network layer or internet layer actually provide the datagram service, so that you are getting a data packet from that the transport layer to the network layer, so that the packet is actually going to be break down, okay, and make the smaller size of packets, so that P1, then the P2, then that the P3, something like that, okay, P4, okay, so that the packets can be travel from any one of the paths. So that P1 is this way, P2 is this way, P3 is this way, P4 is so that this way. So it can become when the connection less service is going to be there, so it can actually follow any path to reach to the destination. So so that the destination node, after getting this all this P1, P2, P3, P4, it should need to be combined or reassemble that the packets, the P1, P2, P3, P4 to get that the original packet. So we'll discuss about this. It say that in this model, a connecting device such as router acts as a switch. So it is talking about that a packet you are sending to that router. The router should need to be decide that you can see that in this example, this router is connected with the 3 routers directly. So that means when a packet arrives from one of its ports interface, the packet it forwarded through another port to the next switch or final destination. So now, in other words, switching occurs at the connecting device. So that means the packet you're sending here, right? So this is a port we have already done into that Cisco packet tester. So you know that here we are having the zero interface interface, right? We are having the interface here like maybe FS00, FS01, or it can be serial 0/0/1, something like that. So that means the router is having the port. So with that, the port he has actually received the packet from node A, and it is going to be actually sent through any one of this port, right? So it can be sent to this router, or it can be sent this router, or it can be sent this router. So that means after getting this packet, after this router R0 getting a packet from A, so it need to be decide himself, right, that to which router or or through which port it is going to be sent that the packet uh, to the next router. So that means this that the process that the router is receiving a packet and it's going to be forwarded to that the next node or next router. So or the next node or next router. So that the procedure is called the switching. Okay, he said the switching occurs at the connecting device. So it's also is said here that when a message reaches the connecting device, a decision needs to be made to select one of the output ports through which the packet needs to be sent out. Okay, we already discussed it. I mean, we have done it into that the Cisco packet tracer. So we know that after receiving that the packet, on that the packet, it is going to be the source and destination IP address with data. So we say that, I mean, the router is going to be take this destination IP address, and from that it is going to be calculate the network address. Okay, and based on that, the network address actually it is going to be send the packet to the next router through that the ports. So you say the connecting device acts as a switch that connects one port to the another port. Yes. So there are two ways that the switching can be done. We say that a router is receiving a packet and he needs to be decide that this packet is going to be sent to the which router, what is to which next node he is going to be send it. So this procedure, that receiving and sending, this procedure we are calling that switching, and it's saying that uh, that the switching can be in two ways it can be done. One is the circuit switching, one is the packet switching. So in the circuit switching, the whole message is sent from the source to the destination without being divided into packets. So that means in the circuit switching, the packets are going to be sent intact. There is no, I mean, the packet is not going to be break down and make that the smaller pieces of packet. It is going to be sent the passage, say that whole message is going to be sent. So circuit switching, maybe that the example is one of the best example can be the LAN phone. So when you're giving the call, when you are talking over the voice call you're doing, that on that time you are actually using the circuit switching, the LAN phone. Okay, LAN phone can be the example of circuit switching. And the packet switching, what is happening? In the packet switching, the message first divided into manageable packets at the source before being transmitted. So that means you cannot send that the whole message in the packet switching at the same time. So you should need to be take the message, you need to be break, or you need to be chop the message, make the smaller pieces of manageable packets, and then one after another smaller packets you're going to be sent. That is simply like this, that what the example I have given here. Okay, so that means the packets are assembled at the destination. That means of course that the p1, p2, p3, p4 I'm talking about. So all these packets, when it is reached to the destination in the network layer, he should need to be actually make them or reassemble them to generate the original message that actually you have break down here. So this is a summary that what we have discussed till now in the previous two slides. The network layer is designed as a packet switch network. The packet at the source is divided into manageable packets called datagrams. Individual datagrams are then transferred from the source to the destination. The received datagrams are assembled at the destination before recreating the original message. All right. So the sender side, you are dividing the packets into the manageable packet size, and those manageable packets you are sending from the source to the destination. And then after receiving all these manageable smaller size packets, you are going to be assembled those packets to recreating the original message. So the packet switch network layer of the internet was originally designed as the connection-less service. Yeah, so but connection-oriented service is also available. So we can see now here with this example figure that we are having here the connection-oriented, connection-less. So another comparison you can get here through that the network layer, that the in the case of the connection-less, what is going to be happen? So packets are uh, break down into 1 to n. Here it is 1 to 4, right? Packet 1, packet 2, packet 3, packet 4. So that as because it's the connection-less service, you know that what is the connection-less service. We have discussed a lot about connection-oriented and connection-less. So it's because it is a connection-less service, so that the packets are going to be sent independently. I mean, with that by using the independent paths. So you can see that the number one packet come to this way, to the destination. Number 2 packet gone this way. Number 4 packets coming to the R3, and then number 3 packets go to these way, R4, R5, and then finally destination. And number 4 packets from R3 it comes to the R5 and then the destination. So it is actually using the independent paths when the connection type is the connectionless service. Of course, this is the packet switch network, remember that. So now if you're coming to that the connection oriented, so that means the connection, that the sender is going to be forced that the packets it has smaller manageable packet it has created is going to be force the packet to send in a single path. I mean created path, same path. All the 4 packets are going to be move serially, okay, by following the same path. So that means it is going to be with the in order fashion, or actually it was the out of order, right? Because this is the connectionless, so it is connection oriented, so it is going to be reach there the in order fashion. So this is the difference actually between the connectionless and connection oriented. If the connectionless, the data is going to be sent independently. In the connection oriented, it is going to be follow the paths. Yeah, you can ask your question, please. Ariful.
No, sir, I didn't.
By mistake, you have
Yes, sir. Yes, sir.
clicked on the restart. Okay, no problem. So do you have any questions here?
No,
স্যার অ্যাকচুয়ালি কোশ্চেন নাই স্যার, কথা বলতাম স্যার। স্যার
Sorry.
এই স্যার যেহেতু আমাদের ক্লাস তো অনলাইনে চলতেছে, এই জন্য তো আমরা ভার্সিটিতে যাইতে পারতেছি না। তা ওগুলো এখন লেকচার গুলো যদি ক্লাসরুমে দিয়ে দিতেন তাহলে ভালো হতো।
No, I said you that the slides we are studying, you can take the screenshot in your mobile phone. You can take the screenshot. Okay, I have yesterday also I have said to you, I'm not going to be share the file with you. Sorry. So that the slides we are discussing in the class, it is your duty that you are taking the screenshot of it. You are using that the mobile phone or laptop for doing this class, so you can take the easily screenshot of that the slides. And if you have missed it out, we are going to be have the consultation hour. So the slides we are discussing on the online, I'll go to again to those slides, and you can online consultation hour day, you can actually take the picture of them. I'm not going to be share the file with you, I'm sorry.
স্যার,
Yeah.
স্যার এই অনলাইন কনসালটেশন আর কবে কবে দিছেন, ডেট দিছেন কোনো?
স্যার আজকে কি নেওয়া যাবে?
Consultation hour, I have not decided it yet. I think it is going to be on tomorrow or maybe the day after tomorrow, and the time is going to be in the evening time, maybe 7:30, something like that. 7 or
Okay, sir.
7:30.
Thank you, sir.
ওকে স্যার।
স্যার
Thank you.
স্যার
Yeah.
আমাদের তো কুইজ নেওয়ার কথা ছিল কালকে, এখন এটা কি অনলাইনেই হবে?
No, it will not help. It will not help. We cannot take that the class test over online. So when the varsity is going to be open, that time we are going to be planned to take the class test, not here.
ওকে স্যার।
Okay, sir.
Yeah.
Sir, our midterm syllabus will be up to today's class.
No, I said up to the 31st. Up to
Tomorrow,
the
sir.
31st. Up to the tomorrow.
Okay.
Tomorrow.
Okay, sir.
Actually, this is that the topic that we are going to be do tomorrow, the IP header format. Okay, so this complete. I think here we are having almost about 10 more slides. Yeah, up to this that your syllabus is going to be. Okay. So we are going to be covered tomorrow that the IPv4 header. Okay.
Okay, sir.
Is there any questions that the things today we have done from there? Okay, then we'll start the discussion tomorrow from here. Okay, slide number 7, the IP header format. Okay.
Okay, sir.
Okay, sir.
Yeah. So I think that for today, I think it's enough. Thank you very much.